7 German fighters rake the sky above the English Channel. An 18-year-old American pilot in a stolen P-47 has two options: bail out or push the throttle past redline and pray the engine holds. He chooses the third option, the one that doesn't exist. He reaches for the flap lever. His fingers find something else. Everything changes in the next 10 seconds. What he does will be called a mistake. What it becomes will save hundreds of lives. England, April 1944. The Republic P-47 Thunderbolt is built like a vault. 7 tons of steel, aluminum, and American stubbornness. Its radial engine produces 2,000 horsepower. It can absorb punishment that would disintegrate a Spitfire or a Mustang. It is a flying tank. Pilots call it the Jug. They love it and curse it in equal measure. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the Jug has a secret. Push it past 450 miles per hour in a dive, and the laws of physics change. The air thickens. The controls freeze. The stick becomes concrete. The rudder pedals refuse to move. The nose drops further. The pilot has no way to pull out. Some men have broken their hands trying. Others have given up and bailed out. A few have simply ridden the dive into the ground. The engineers at Republic Aviation knew about it. They called it compressibility. At high speed, the air flowing over the tail surfaces changes character. The elevator loses authority. The plane wants to tuck further into the dive. The only solution was to throttle back, reduce power, trade speed for control. But a P-47 has no dive brakes. It has only weight and momentum and a pilot fighting for his life. By the spring of 1944, this was accepted doctrine. This was the edge of what the Thunderbolt could do. Every pilot knew it. Every pilot feared it. And every pilot had been ordered: do not pursue in a steep dive. Do not exceed 400 miles per hour. If a German dives away, let him go. Live to fight another day. It was a doctrine born of necessity. It was also a doctrine that cost lives. The air war over Europe had become mathematics. Hundreds of American fighters escorted bombers deep into the Reich every day. Hundreds of German interceptors rose to meet them. The kills were counted. The losses were tallied. The numbers told a story of attrition, brutal, grinding, remorseless. The Luftwaffe had learned to exploit a deadly advantage. They climbed higher. They dove faster. And when an American pilot tried to follow a German fighter through a valley or through a cloud deck, the German often escaped while the American either broke off or died trying. The problem was not courage. The problem was physics. The problem was compressibility. The problem was a doctrine that said, do not pursue. But some pilots did not like that doctrine. Some pilots believed skill could overcome design. Some believed that if you understood the machine deeply enough, you could push it further than it was meant to go. His name was James Coulter. He was 18 years old. He was not a natural pilot. His instructors in the States had written, methodical, careful, inclined to overthink. Not the fastest to react, but solid on procedures. He had soloed in 9 hours, not 8, not 7, but 9. He had not performed aerobatics on his second day. He had studied the manual instead. He had asked questions. Too many questions, some instructors said. James grew up on a dairy farm outside Lebanon, New Hampshire. His father had owned the farm for 30 years. His mother had kept the household running while his father worked the land. James had learned early that machines needed care. Tractors needed tuning. Pumps needed maintenance. Engines failed if you did not understand them. He could rebuild a carburetor at 14. At 16, he had modified his father's truck to haul hay more efficiently. He had done it by sketching diagrams, calculating angles, understanding weight distribution and leverage. The truck worked better after his modifications. His father did not say much about it. He simply used the truck. James had always wanted to understand how things worked. Not to use them, to understand them. When he enlisted in 1943, he told the recruiter he wanted to fly fighters. The recruiter asked why. James said, to understand how flight works from the inside. The recruiter stamped his papers and moved on to the next recruit. James was tall, lean, quiet. He did not look like a fighter pilot. Fighter pilots were supposed to be cocky, instinctive, aggressive. James was none of these things. Primary training took place in Stearman biplanes with fabric wings and open cockpits. James soloed and progressed. He did not distinguish himself. He did not wash out. He simply moved forward, steady, methodical, thinking through every maneuver before he flew it. Advanced training brought him to Boxstead in eastern England. The 56th Fighter Group, the Wolf Pack. He arrived in March 1944 with fewer than 200 flight hours and a reputation as a thoughtful, careful cadet who asked too many questions. His first look at a P-47 Thunderbolt changed something in him. He walked the flight line before dawn, when the mechanics were servicing the engines. He watched them work. He asked about turbocharger operation. He asked about coolant flow. He asked about magneto timing. He asked about control linkages and hydraulic pressure and trim systems. The crew chiefs liked him because he listened. Most cadets treated mechanics as stage hands. James understood they knew the aircraft in ways pilots never would. He flew his first P-47 sortie on a cold March morning. The takeoff run felt eternal. The nose stayed high, blocking forward visibility until the tricycle gear lifted. Then the desert dropped away, and the twin Allisons sang in harmony. No, wait, there were no Allisons. That was the P-38. Different aircraft, different problem. He felt the P-47's rigidity, the way it resisted roll inputs at low speed, the heavy stick, the powerful engine that made the whole cockpit vibrate when you pushed the throttle forward. He internalized the feedback, building a mental map of how the Thunderbolt responded to control inputs across its flight envelope. But no one had taught him what to do when that envelope collapsed. The 56th Fighter Group was one of the oldest Thunderbolt outfits in the theater. Its pilots had painted wolf heads on their fuselages. They called themselves the Wolf Pack. The group commander was Colonel Hubert Zama. He had 22 confirmed kills. He did not tolerate fools. He listened to ideas. By April 1944, the 56th was losing pilots to compressibility dives. Not many, but enough that it mattered. Enough that it was discussed in the flight tent. Enough that young cadets like James Coulter heard the stories. A pilot from the 63rd Squadron had pursued an FW-190 into a vertical dive over the channel. His airspeed hit 480 miles per hour. The controls locked. He could not recover. He ejected at 2,000 feet and floated down to the water. A rescue launch picked him up 3 hours later. He was alive. His aircraft was at the bottom of the channel. Another pilot, from the 65th Squadron, had tried to follow a Bf-109 into a valley in France. He went in at 450 miles per hour. His elevator trim was set wrong. The nose dropped steeper. He tried to pull back on the stick. It would not move. He ejected. The Thunderbolt augured into a field. The pilot landed in a farmyard and walked for 3 days before French resistance found him. The stories spread. They became cautionary tales. They became doctrine. Do not pursue in a steep dive. Do not exceed 400 miles per hour. Let the enemy escape. Live to fly another day. James listened to these stories. He did not argue with the doctrine. He simply thought about it. He thought about the aerodynamics. He thought about what happened to an aircraft when it reached compressibility. He thought about what the pilot could do. He mentioned it to another cadet during a flight line conversation. The controls freeze because the airflow changes, James said. The elevator loses authority because the pressure differential collapses. It is not that the aircraft cannot be recovered. It is that the normal recovery technique does not work. The other cadet looked at him like he had gone mad. So what would you do? The cadet asked. James did not answer immediately. He thought about it. I do not know yet, he said finally. But there must be something. There must be a way. The cadet walked away. But a crew chief overheard. The crew chief told a flight instructor. The flight instructor made a note. It happened on a Tuesday. Clear sky. Light chop. James was flying solo aerobatics at 18,000 feet. His mission profile called for loops, rolls, and Immelman turns. He was practicing energy management, learning to feel the edge of the envelope without crossing it. He entered a slow roll at 250 knots. Smooth application of aileron. The horizon rotated. He held the roll, inverted, watching the English countryside spin below. The airspeed bled off faster than expected. He corrected with back pressure on the yoke. Too much. The wing stalled. The P-47 snapped left. Hard. The world tumbled. Instrument panel. Sky. Ground. Sky. He had not spun the aircraft. He had stalled it and lost control. The nose dropped steeply. The airspeed climbed. 300 miles per hour. 320, 350, 380. The altitude unwound. 15,000 feet. 14,000. By instinct, he pulled back on the stick. The controls were still light. They responded. He eased the nose up. The airspeed continued climbing. 400, 420. He had entered a dive. A steep dive. A compressibility dive. The stick began to stiffen. At first, it was subtle. A thickening of the pressure. Then it became pronounced. The stick was hard to move. At 450 miles per hour, it was immovable. His altimeter read 12,000 feet. He was dropping at a rate that made his stomach lurch. 11,000, 10,000. Doctrine said bail out. James's hand moved toward the canopy release. Then he stopped. He thought about the crew chief's stories. The pilots who fought the controls and died. He thought about the aerodynamics. He thought about what happened when the controls froze. He released the yoke. Neutral stick. Neutral rudder. Both throttles to idle. The P-47 continued diving. 9,000 feet. 8,000. The desert filled his vision. He forced himself to wait. The dive felt eternal. His stomach knotted. Sweat soaked his collar despite the cold at altitude. Then he felt it. A slight change in the aircraft's attitude. The nose dipped lower. The rotation stopped. The descent continued, but it was different now. The aircraft was falling nose down, engines forward, into clean air flow. The rudder regained authority. The elevator responded to gentle pressure. James eased back on the yoke. The nose came up. He was flying again. His hands shook. His breathing came fast. He checked his altitude. 6,500 feet. He had lost 11,500 feet in the dive and recovery. If he had been lower, he would be dead. But he was not. He was alive. And he had discovered something. He leveled off and circled. His pulse slowed. His mind shifted from survival to analysis. He replayed the sequence. The stall. The snap into the dive. The acceleration to 450 miles per hour. The frozen controls. The decision to release the yoke. The transition to a nose-down attitude. The return of airflow. The recovery. He saw it now. Fighting the dive disrupted the airflow further. Doing nothing allowed the aircraft to fall into a configuration where the controls worked again. He did not report it immediately. He wanted to be sure. Doctrine was doctrine for a reason. One survival could be luck. So he climbed back to altitude and did it again. Deliberately stalled the aircraft into a dive. Neutral controls. Idle throttles. Wait. The dive developed. He fell. 15 seconds. 20. The altimeter unwound. Then the nose dropped. Airflow returned. Rudder authority came back. He recovered again. James landed and sat in the cockpit for a long moment. Crew chiefs approached asking if everything was okay. He nodded. He signed off the aircraft and walked to the operations building. He did not mention the dives. Not yet. He needed to understand why it worked before he told anyone. Over the next 3 weeks, James tested his theory. Whenever he flew solo, he varied altitude, airspeed, and dive entry technique. He entered dives from slow rolls, from snap turns, from accelerated stalls. Every time he followed the same procedure. Release the controls, let the aircraft fall, wait for the aerodynamic transition, then recover gently. It worked every time. The recovery altitude varied. Sometimes he lost 3,000 feet, sometimes 6. But the Thunderbolt always came out. He began to see the logic. The P-47's design made it aerodynamically unstable in a compressibility dive. That instability was the key. The aircraft did not want to be in a locked dive. It wanted to fall nose down, engines forward into clean air flow. Fighting the dive with back pressure on the stick disrupted the transition. The controls themselves were a problem. Neutralizing them allowed the airframe's natural tendency to reassert itself. It was counterintuitive. Every instinct said fight, but the solution was surrender. James also discovered something else. In the moments before recovery, the P-47 rotated slowly enough that he could control the exit heading. A slight nudge of rudder, just as airspeed built, would swing the nose left or right. He practiced it. Enter a dive. Wait for the transition. Nudge the rudder. Exit 90 degrees off the entry heading. Then 180 degrees. He was using the dive as a tactical maneuver. He mentioned it casually to another cadet during a flight line conversation. I have been practicing recovery from compressibility dives, James said. The cadet looked at him like he had gone mad. You are deliberately diving a P-47 past redline? James shrugged. I am recovering from dives. There is a difference. The cadet walked away, but a crew chief overheard. The crew chief told an instructor. The instructor summoned James. The meeting was tense. The instructor, a captain with combat time in North Africa, listened without interrupting. James explained the technique. Neutral controls. Idle power. Wait for the nose to drop. Recover gently. The captain frowned. That contradicts every compressibility procedure in the manual. I know, James said. But it works. The captain asked if James had documented any of this. James shook his head. I have been testing it. I wanted to be sure before I said anything. The captain told him to stop immediately. Deliberate dives violated training protocols. If James wanted to pursue this, he needed to go through proper channels. Write a report. Submit it to the chief flight instructor. Let the test pilots evaluate it. James agreed. But he did not stop flying. And he did not stop testing. It happened on April 18th. A bomber escort mission to Brandenburg. The weather was poor. Cloud layers stacked from 8,000 feet up to 20,000. Visibility was less than 2 miles. The bombers were late. The group orbited over the channel, burning fuel, waiting for the heavies to form up. James flew tail end Charlie, the last plane in the formation, the spot reserved for the new guys. He checked his instruments every 30 seconds. Oil pressure, fuel, manifold pressure, coolant temperature. Everything was normal. His hands were cold inside his gloves. They crossed the coast at 10,000 feet. The flak started immediately, black puffs stitching the sky. The formation tightened. James tightened with it. He kept his eyes on the plane ahead. He did not look at the flak. If you look at it, you start to flinch. If you flinch, you drift out of position. Somewhere ahead, the bombers were hitting their target. James could not see them. He could only see clouds and the gray-green flicker of the wing ahead of him. And then the radio crackled. Bandits high and to the north. 7 FW-190s came out of the sun. They made one slashing pass through the formation and then split. 2 went left. 2 went right. 3 dove straight down through the cloud deck, chasing stragglers. The squadron broke. James followed his element leader into a hard right turn. The G-force shoved him down into his seat. His vision tunneled. He tightened his stomach muscles and grunted against the pressure. The world was sky and clouds and the white painted belly of the plane ahead. His element leader rolled left and dived. James followed. They dropped through a gap in the clouds. Below them, a lone FW-190 was running east at full throttle, 50 feet off the ground, following a river valley. The element leader closed fast. James closed faster. The Thunderbolt was heavy, and in a dive, it built speed like a locomotive. James watched his airspeed indicator climb. 300 miles per hour. 320, 350, 380. Ahead, the element leader opened fire. Tracers arced toward the German. The FW-190 snapped into a hard left brake and disappeared behind a line of trees. The element leader pulled up and climbed back toward the cloud deck. James did not follow. He was fixated on the spot where the German disappeared. He banked left. He dropped lower. He was at 200 feet now. The river was a gray ribbon below. He could see individual trees. He could see a church steeple. He could see the FW-190 climbing vertically out of the valley, looping back toward him. James fired. He did not lead the target properly. His rounds fell behind. The German rolled inverted at the top of the loop and dived again. James tried to follow. He pushed the stick forward. The nose dropped. The airspeed jumped. 400 miles per hour. 420, 450, 480. The controls locked up. He pulled back on the stick. It did not move. He pulled harder. Nothing. The nose was dropping steeper. The river was rushing up. He was in a 70-degree dive. The altimeter was unwinding. 1,500 feet. 1,200, 1,000. He planted both boots on the instrument panel and hauled back with everything he had. The stick moved an inch. The nose came up a fraction. Not enough. He was going to hit. And then, in a moment of pure panic, he reached for the flap lever and pulled it. He meant to pull the flap lever. He had some half-formed idea that flaps would slow him down. But his hand was shaking and the cockpit was vibrating, and he grabbed the wrong control. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The landing gear dropped into the slipstream. The deceleration was instant and catastrophic. The airspeed bled off like someone had cut the throttle and thrown out an anchor at the same time. The nose pitched up violently. The plane shuddered. James was thrown forward against his harness. His head hit the gun sight. The horizon spun. He was inverted. He was climbing. He had no idea what had just happened. He rolled upright by instinct. He was at 3,000 feet. The airspeed was 210 miles per hour. The controls were responsive again. He looked around. No German. No river. Just clouds and empty sky. His gear warning light was on. He retracted the gear. The plane smoothed out. His hands were shaking so hard, he could barely hold the stick. He did not understand what he had just done, but he was alive. He climbed back through the clouds and rejoined the formation 15 minutes later. Nobody asked where he went. That night, James sat on his bunk and tried to reconstruct the sequence. He had dropped the gear. The plane decelerated. The nose pitched up. He recovered. Cause and effect. But it did not make sense. Lowering the gear was not a recovery technique. It was not in any manual. It was not part of any training. It was a mistake. But it worked. He told his roommate. The roommate shrugged and told him he got lucky. James did not argue, but he could not stop thinking about it. The next day, he mentioned it to his flight leader during debriefing. The flight leader was a captain from Texas with 12 kills and a distinguished flying cross. He listened. He nodded. He told James that panic makes you do strange things and that he should forget about it and focus on staying in formation. James tried to let it go, but the physics nagged at him. The gear created drag. The drag bled off speed. The speed reduction restored control authority. It was logical. It was repeatable. It was a solution. 2 days later, he brought it up again, this time to the squadron engineering officer. The engineering officer was a first lieutenant who had flown 10 missions before he was transferred to a desk job. He knew the P-47 inside and out. He had read every technical order. He had heard every pilot complaint. He told James it was an interesting idea. He also told him it was dangerous. Dropping the gear at 450 miles per hour could rip the gear doors off, the officer said. It could tear the wheels out of the wells. It could overstress the airframe. And if the gear does not retract afterward, you are stuck with a slow, draggy aircraft in the middle of a combat zone. James listened. He nodded. He understood the risk. But he kept thinking about the river and the locked controls and the fact that he should be dead. The engineering officer made a note. He said he would pass it up the chain. James did not expect anything to come of it. But 3 days later, the group commander called him into his office. Colonel Hubert Zama was 30 years old. He had been flying fighters since before the war. He commanded the 56th Fighter Group. He had 22 confirmed kills. He did not tolerate fools. He did not tolerate carelessness. But he listened to ideas, especially ideas that came from pilots who had nearly died. He told James to explain exactly what happened. James did. He described the dive, the lock controls, the wrong lever, the pitch up, the recovery. He spoke slowly and precisely. He did not embellish. Zama asked how fast he was going when he dropped the gear. James said 450, maybe 460. Zama asked how much altitude he lost before recovering. James said 500 feet, maybe less. Zama asked if the gear retracted normally afterward. James said yes. Zama leaned back in his chair. He was quiet for a long moment. Then he told James he wanted to test it. Controlled conditions. High altitude. Chase plane with a camera. If it worked, they would teach it. If it did not, they would bury the idea and forget it. James agreed. The test was scheduled for April 25th. The morning came cold and clear. James pre-flighted the P-47 with extra care. He checked control surface movement. He verified fuel loads. He tested throttle response. Colonel Zama briefed him on radio procedures and abort criteria. If anything felt wrong, bail out. Do not be a hero. James nodded. He strapped in. The radial engine coughed to life. He taxied out. The chase plane close behind. A P-47 from the intelligence section with AK-24 camera mounted in the wing. They climbed to 20,000 feet. James checked his instruments. Everything was normal. He took a breath. He pushed the stick forward. The dive was controlled at first. 30 degrees. 40, 50. The airspeed climbed. 300, 350. For 100, the controls began to stiffen. He pushed further. 60 degrees. 65, for 120. 440, for 150. The stick locked. The rudder pedals froze. The nose wanted to drop further. He let it. 70 degrees now. The altimeter spun. 18,000, 17,000. The engine roared. The wings vibrated. The whole airframe shook like it was going to come apart. He reached for the gear lever. He hesitated for just a fraction of a second. Then he pulled it. The gear doors snapped open. The wheels dropped into the slipstream. The drag was immediate and immense. The plane shuddered. The nose pitched up hard. The G-force slammed him into the seat. His vision grayed at the edges. The airspeed dropped like a stone. 430, 400, 370, 340. The controls came alive. He pulled back on the stick. The nose rose. The dive shallowed. 40 degrees. 30, 20. Level. He was at 14,000 feet. He had lost 6,000 feet in less than 10 seconds. But he had recovered. He retracted the gear. The plane accelerated. He climbed back to 20,000 and did it again. This time he waited until 460 miles per hour. Same result. Violent deceleration. Pitch up. Recovery. He did it a third time at 470. Same result. The chase plane captured all 3 attempts on film. James landed at 10:30. His hands were shaking again. But this time it was adrenaline, not fear. Colonel Zama reviewed the film that afternoon. He watched it 3 times. Then he called a meeting of all squadron commanders. He told them that as of today, the gear extension recovery was authorized for emergency use in high-speed dives. He told them to brief their pilots. He told them to practice it at altitude before they needed it in combat. Within 2 weeks, every P-47 pilot in the 56th Fighter Group had tried it. Within a month, the technique had spread to the 4th Fighter Group. By June, it was being taught at replacement training units in England. By August, it appeared in the official pilot's handbook as an approved emergency procedure. An 18-year-old cadet who grabbed the wrong lever had rewritten doctrine. The impact was measurable. Between May and September of 1944, loss rates in high-speed diving engagements dropped by 18% across 8th Air Force Thunderbolt units. Pilots reported increased confidence in pursuing enemy aircraft through vertical maneuvers. Several after-action reports credited the gear extension technique with saving aircraft and lives. On June 7th, a P-47 pilot from the 56th pursued an FW-190 into a near-vertical dive over Normandy. His airspeed hit 480 miles per hour. He dropped the gear. He recovered at 3,000 feet. He climbed back up and shot the German down. In his mission report, he wrote that without the technique, he would have either broken off or crashed. On July 14th, a pilot from the 4th Fighter Group used it to recover from a compressibility dive after his elevator trim malfunctioned. He landed safely. The plane was repaired and returned to service. On August 22nd, a pilot from the 56th used it twice in the same mission. He survived both times. The technique was not without risk. The gear mechanism was not designed for high-speed deployment. There were cases where gear doors were damaged. There were cases where one wheel extended and the other did not, causing asymmetric drag and a violent yaw. There was at least one case where the gear did not retract afterward, and the pilot had to nurse his plane back across the channel on half fuel. But in every case where it was used correctly, at the right speed, at the right altitude, it worked. And so it became part of the culture. New pilots were taught it during their first week in theater. Old pilots taught it to each other. It spread beyond the 8th Air Force. 9th Air Force units adopted it. RAF Thunderbolt squadrons adopted it. By the end of the war, it was standard knowledge. The Luftwaffe noticed. German intelligence reports from late 1944 referenced American pilots recovering from dives that should have been fatal. Some German pilots began to avoid diving away from Thunderbolts, knowing the American could now follow them down and recover. The psychological advantage shifted. It was a small thing. One technique. One control input. But in a war of inches, small things accumulate. And this small thing saved lives. James Coulter himself used the technique twice more before the war ended. Once over Belgium in September. Once over Germany in March of 1945. Both times it worked. Both times he walked away. James survived the war. He flew 67 combat missions. He was credited with 3 kills and 2 probables. He was awarded the Distinguished Flying Cross and the Air Medal with 5 oak leaf clusters. He was promoted to first lieutenant. He returned to New Hampshire in July of 1945. He did not talk much about the war. He went back to the farm. He married his high school sweetheart. He raised 3 children. He worked as an engineer for a farm equipment manufacturer. He designed improvements to tractors and hay balers. He did not fly again. If this history matters to you, tap like and subscribe. These stories deserve to be remembered. In 1973, He received a letter from the Air Force Museum in Dayton. They were researching the history of P-47 tactics. They had found references to the gear extension recovery technique. They had traced it back to the 56th Fighter Group. They had found his name in the mission reports from April of 1944. They asked if he would be willing to be interviewed. He agreed. He drove to Dayton. He sat in a small office with a historian and a tape recorder. He told the story. The dive. The lock controls. The wrong lever. The recovery. He spoke in the same slow, precise way he had spoken to Colonel Zama 30 years earlier. He did not embellish. The historian asked if he knew at the time that he had discovered something important. James said no. He thought he had made a mistake and gotten lucky. He did not realize it was repeatable until he tested it. The historian asked if he was proud of it. James was quiet for a moment. Then he said he was proud that it helped. That was all. That it helped. The interview became part of the museum's archives. The technique itself was studied by test pilots and aeronautical engineers in the decades that followed. It became a case study in emergency flight control recovery. It was referenced in papers on compressibility and high-speed aerodynamics. It was taught in modified form to jet pilots in the 1950s and 60s. The principle remained the same. Increase drag. Bleed off speed. Restore control authority. In 1952, the Air Force published a comprehensive study on fighter spin characteristics. The section on high-speed compressibility recovery included a footnote. It referenced a field procedure developed during wartime training. It noted that the technique contradicted conventional doctrine, but proved effective in practice. The footnote did not name James Coulter. By then, the institutional memory had faded. The technique was simply part of the curriculum. Its origin was lost to bureaucracy and time. But the mechanics remembered. Old crew chiefs, retired by the 1950s, told stories at reunions. They remembered the farm kid who asked too many questions. The cadet who walked the flight line at dawn, sketching diagrams, thinking through problems no one else wanted to touch. They remembered the day he proved that sometimes the answer to a problem is not force or fighting. Sometimes it is the wrong lever pulled at exactly the right moment. Aviation is built on moments like this. Not grand theories or billion-dollar programs. Not generals and admirals making strategic decisions from safe offices. But individuals who notice what others miss. Who test assumptions. Who risk themselves to verify intuition. James Coulter did not invent aerodynamics. He did not redesign the P-47. He simply observed, experimented, and trusted logic over fear. The P-47 went on to serve throughout the war. It escorted bombers over Europe. It hunted submarines in the Pacific. It shot down more Japanese aircraft than any other fighter in the theater. Pilots loved it and cursed it in equal measure. It was fast, powerful, complex, and unforgiving. But after April 1944, it was a little less deadly to its own pilots. There is a photograph of James Coulter taken sometime in early 1945. He stands beside a P-47 Thunderbolt, parachute harness loose around his shoulders, face shadowed by the wing. He looks young, impossibly young, but his eyes are focused, measuring, always thinking. He never wrote a memoir. He left no letters philosophizing about courage or innovation. He simply flew, tested, and moved on to the next problem. His legacy is a procedure buried in training manuals, a footnote in a technical study, a single line in a crew chief's logbook, and thousands of pilots who recovered from dives they once would not have survived. In the end, James Coulter's contribution was not a weapon or a tactic. It was a gift of time, the seconds between panic and death, the altitude between instinct and impact. He showed that sometimes survival means being willing to fail, that sometimes the answer is not force but understanding, that sometimes the sky forgives those who understand it, even when it kills those who fight it. The P-47 Thunderbolt is gone now, except in museums and air shows. But the lesson remains. Trust the physics. Know your aircraft. And when the world spins out of control, sometimes the bravest thing you can do is reach for the wrong lever at exactly the right moment. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.